Hello, today we are talking about climate and weather. So first of all, weather is the day-to-day conditions in the troposphere. And that can include temperature, precipitation, humidity, and lots of other things that we consider like when we watch the weather forecast. But then we have climate, which is over a very long period of time. And it's the general pattern of atmospheric conditions over a very long period of time, and this mostly includes precipitation, temperature, and humidity. So the climate is determined by several things, including the prevailing winds, ocean currents, and the properties of land, water, and air. There we go. So let's talk about prevailing winds first. So prevailing winds are the overarching wind pattern in a large area. So they are driven by uneven heating of the Earth's surface. So as you can see right here, we have direct sunlight, the most direct sunlight rays hitting at the equator. I know that you were all very impressed with my drawing abilities here. So if you can't tell, this is South America, North America, Africa, Europe, Greenland. The rest of the world got chopped off. So we have the most direct sunlight hitting right here, and so because of that, the air is going to get warm, the particles are going to spread out, it's going to become less dense, so it's going to rise. So we have rising air coming off of the surface of the Earth at the equator, and so then once it gets up higher into the troposphere, we know that with altitude in the troposphere, temperature decreases, so this is going to cool and condense and continue traveling, and so cool and condense, the particles are closer together, it's more dense, so it's going to sink. So it's going to sink around the 30-degree north latitude and the 30-degree south latitude. And so this pattern of uneven heating and cooling drives the winds. So as you see, in this area we have the surface winds are going from the 30-degree north to the equator, so that is the direction of our winds there, and you can see here it's going from 30 degrees south to the equator. So it's going to go like this here, and again here. Oh wait, yep, and so we name winds for the direction that they are coming from. So we have, these are coming from the east, so they are easterlies. Easterlies. These are coming from the west, so they're called westerlies. Westerlies. Okay, and then up at the very tippy top, we have polar winds, going like that, and like that. Okay, so that's the prevailing winds. And so these little cells are called Hadley cells. I don't know that that's super important for you to know, but it's a cool thing to know. So where the warm, moist air is rising, it's creating more precipitation in that immediate area. So in the tropics, right around here, you're getting more precipitation because you have warm, moist air rising. It's creating clouds right up here where it gets cold enough, and then raining back in that same general area. And then over here where you have cool air sinking, dry air sinking, you end up with deserts. So right along here, we have a desert in the middle of Central America and Mexico. We have the Sahara Desert right here. Same thing over here. I think my drawings are off. But there's some deserts down here, and the Namib Desert and the Kalahari Desert are down here. Australia's Great Outback is also in that same general area. So we get a lot of deserts where you have dry air coming in, and tropical wet places where you have moist air rising, condensing, and raining back down. Okay, so let's talk about ocean currents. So we have the same basic principle occurring with ocean currents. So they are driven by the uneven heating of the Earth salinity of the water, and prevailing winds. So we'll start off with the uneven heating bit. So it's the same general process as with the winds. So along the equator, the water is getting warmed, and so it's rising to the surface, it's becoming less dense, and it floats away from the point of where it's warm. So we have warm water currents, they generally originate at the equator. So this is the Caribbean current, turns into the Gulf current, into the North Atlantic drift. And then once it gets up into the poles, or the water gets up down into the poles, it obviously cools because there's not as much direct sunlight. There's already colder water there and icebergs and that sort of thing. So the water cools. So when it does that, and when it freezes, only the fresh water freezes. It leaves the salt behind. So that means that the salt water at the poles is getting more dense. Number one, because it's cooling, the particles are getting closer together, and so it's more dense for that reason. And then secondly, because when it's freezing, the salt is being left behind in the water. So you're removing water particles but adding salt particles. So it's becoming even more dense because you have more particles in the same unit of space. And so that cold water is going to sink, and it's going to drive a circulation, and it's going to travel towards the equator, and it's going to drive a global circulation of water. And then also with the prevailing winds, so the winds blow constantly across the water, and the friction between the water and the air kind of drags that surface layer of water along. So if we remember our prevailing winds, between 30 degrees north and the equator, we have winds blowing from east to west, and you can kind of see that influencing some of the currents, like here. So blowing from east to west. Okay, let's see here. So with both air currents and water currents, they are affected by something called the Coriolis effect. So if you notice, when I drew air currents, I did not draw them in straight lines going straight from east to west or north to south. I drew them with a curve to them. So the Coriolis effect is the deflection of objects like airplanes, water molecules, air particles, due to the rotation of Earth. So in the northern hemisphere, things deflect to the right of their origin. In the southern hemisphere, things deflect to the left of their origin. It's really important that you look at from their origin, not whether things are going north or south or east or west. It's from their origin. We have the Earth. It's rotating this direction. All right. So if we have the marker, and it is a lovely little airplane, and it's trying to fly from Greenland just straight down to the equator. To maybe, if it goes in a straight line, then it would hit Brazil. Okay, so we have our marker. It's moving in a straight line. So I'm not going to move the marker. It's still going in a straight line. But the Earth is rotating underneath it. So as the Earth rotates underneath it, it kind of veers off to the right if it's traveling in a straight line. Same thing if we're trying to go from Brazil back to Greenland. If I move the marker in a straight line, but then the Earth rotates, it veers off to the right of its point of origin. And I did that a little bit yeah. So that's in the northern hemisphere. If we're in the southern hemisphere, and we do the same thing, let's see, find the equator. I think I might have already passed it. Oops. Yep, already passed it. Okay, so the equator, here-ish. Same thing, so the Earth is rotating that way. So things veer off. So you'll notice that currents veer in the northern hemisphere to the right of their point of origin. And so if we're facing this way, that is to the right of the point of origin. But in the southern hemisphere, they veer to the left of their point of origin. The left of their point of origin. Okay. Whew. Okay. So there are a few properties of air, water, and land that drive some climate factors. So when the sun heats the water evaporates, obviously, and moves up because it's less dense. And so it's removing air particles from this space, so the pressure is low. So you have fewer air particles pressing down on this area, so we have a little bit of pressure, so the pressure is low. And then that moist air rises. Once it gets high enough in the troposphere, it cools and it rains. So this is why coastal areas tend to have a lot more rain than inland areas. And then the air continues to travel because things travel. And so since it's raining here, we have a little, and all these air particles are moving here, we get a high pressure. And then it travels over here, and we have a low pressure. Because now air particles start sinking back down because they're cool. And so, so things start sinking back down because they're cool. And then again, air molecules tend to travel from high pressure to low pressure. And so they'll move towards the low pressure system. So we tend to be a little bit more dry inland and a little bit more wet towards the coast. And then last but not least, landforms have a pretty big role to play in an area's climate. So if you have some nice warm moist air from a body of water, maybe an ocean, maybe a big lake like the Great Lakes, it's going to travel inland because, well, depending on the pressure, it's going to most likely travel inland. But as the warm, moist air gets to a mountain, it has to rise to go up and over it. So as it rises to go up and over it, it cools down, and cool water droplets condense and form clouds, and they rain. So all that rain tends to stay on one side of the mountain. We call that the windward side of the mountain. And then, so the air has lost all of its moisture on this side of the mountain, but it's still cold. It travels up and over the mountain. It doesn't have any moisture anymore. It warms as it goes down. And so on the leeward side of the mountain, so this side of the mountain, it tends to be really dry and desert-like. Well, maybe not desert, but more arid climate anyway. So we have more arid climates on the leeward side of mountains, more moist climates on the windward side of mountains. And it doesn't matter. It could be west to east, east to west, north to south. It just depends on which way the mountain range is, where the body of water is, and what the prevailing winds are as to how the climate's going to turn out. Okay, so now we know the basic things that create climate. And so the climate, which is the temperature and the precipitation of an area over a very long period of time, tends to determine the vegetation community. So in this area in North Carolina, we have a fairly moist climate, so we can grow lots of trees. We have a temperate climate, so we can have trees that only photosynthesize during the summer, and we can also have trees that photosynthesize all year round, because it never gets too cold for one type or the other. If you go farther north into like the taiga or the tundra, they don't get enough moisture to support trees and vegetation, or their growing season, it's not warm enough, long enough to support big vegetation like trees. And so the vegetation determines the type of animals and things that we're going to find there. And so climate overall is the big determiner of the different types of biomes. All right, so hopefully that is clear. If you would like better pictures, because my drawings are not good, then section 7.1 of your textbook is a great resource to read. I highly suggest at least looking through the pictures. If not reading it, it's only a couple of pages long. All right, see you in class.